Hello and welcome all. Today I'm going to be showing you how to do data analysis on a dataset which contains Google Apps ratings. So I have this dataset with me over here in this Excel sheet. So this is a CSV file and it contains 13 features or 13 columns, namely the app's name, its category, its genre, the rating, the reviews it got, its size, its installs, the type, its price, last updated, current version, and Android version. So we see here that there is a mixture of all kinds of data. So here you see that there are string type of data. Here also string types of. Here you can see that there is a float type of data, an integer type of data maybe in reviews, which is obvious. Then in size, because it's ending with M, we have again a string type of data. Installs are ending with plus, so again, it's a string type of data. Type is obviously a string type, but what about price? So let me apply a filter over here and we'll see all the possible values that this particular column has. So although it has a 0, but all the other price values are starting with a dollar. Okay, so this again price value is a string. Content rating, genres, last updated, current version, Android version is again a string. So now we have analyzed, we have seen what the data type of our uh, data set is, and we can see that it contains a lot many rows going deep down to somewhat like 10,000 maybe. So don't worry about that. You don't have to scroll down all the way through your Excel sheet. We can do it simply using Jupyter Notebook. So this is the topic of today. But before getting started, I would like you all to start your Anaconda Navigator. As soon as you go into that, you'll find your Jupyter Notebook launch button. I've simply pinned it to my taskbar, so you can start it from over here also. So this particular folder of mine, which contains my notebook, is in my documents, the data analysis folder, and here's my notebook. This is the dataset I'm using. So please store your notebook and the dataset in the same folder. And if you are starting a new, fresh, so just go over here, click on new, and then click on Python 3. So a new notebook will open up for you. And you can change the title to like predicting Google Apps ratings. Okay, and get started with it. So I'll just close this up because I have a notebook ready. As we all know that notebook is nothing but a kernel type of an IDE that lets you write your code and produce results as soon as possible. But unlike the kernel, it does not lose your code. It saves it in an IDE format or a notebook format. And so goes my extension, which is IPYNB. So this just means interactive Python notebook. So now first thing is import the required modules. So modules are the libraries that are written over Python for specific task. And I have pandas, numpy, cborn, matplotlib. And I've given them an alias of pd, np, sns, plt, which are the famous aliases for these kind of modules. And then I've initialized the matplotlib inline. So just press in shift and enter to run this cell. And now I want this data set of mine over here to be uploaded into my notebook's kernel. So for that I'm using pd.read_csv and passing in the path of where my data set is. That's why I've said please store your data set along with your notebook. Make it a handy practice. So now this data set has been stored into this variable Google_data, which is the variable name I have given. You can give any of the names. The most common one is df, which stands for data frame. So As you have seen that we have many types of data which can be float, integer, string, or even a boolean. Data frame is the data structure of pandas. So all these strings, floats, ints can be stored in data structures that the Python provides, which are list, tuple, dictionary, sets, and frozen sets. So list is nothing but a mutable type of an array. Tuple is immutable arrays. Dictionary is hash tables similar to these kind of data structures, and sets. But pandas have two data structures. The first one is a series and the second one is a data frame. So data frame stores all kinds of data that is float, int, string, boolean in columns and rows. So just the way we saw in this Excel sheet, so means that in two-dimensional form, it stores these kind of data in itself. A dictionary can be converted into a data frame, while list and tuples can be converted into series, because series is a one-dimensional labeled array capable of holding any data type, and it's similar to extracting one column from over here and producing it with appropriate indices, be it 0, 1, 2, 3, or whatever kind of indices that you have given while converting. So back to your notebook. If I did a quick type of this Google underscore data, I'll get a data frame. So I'm right about my explanation. And let's inspect the first 5 rows by invoking this function, which is head. And we see that we have got the same 5 rows that we had over here. I've scrolled it down. We are getting the first 5 rows along with the header. So this is how you can view all your rows and columns in your notebook as well. So let me do a quick 10 rows and I get 10 rows from here. You can also get to see all kinds of rows from the flip side, that is from your back side. And this is what I'm getting. So I have 13 columns and I have values in them. Now let's do a quick how many rows, how many columns does this data set have. So for that you have an attribute which is shape, and I ran over this attribute on the variable Google underscore data and I get 10840 as my number of rows and 13 columns. So now after having all this data in my kernel, loaded into my kernel, let's do a quick summary stats. So please describe the data, and I'm getting only one column which is numerical, and the central limit theorem has been applied to it, and I'm getting mean, standard deviation, minimum, maximum, interquartile ranges. So this is the only available column to us that is in numerical form. All other are categorical, as we had seen earlier. So if I plotted a box plot on this numerical column, I'm getting that most of my data is concentrated from this range, that is from 2.5 to 5, but I'm having an outlier over here, just one outlier, which is somewhere between 17.5 to 19, or must be 19 itself. So let's check it out. Now I also drew a histogram to see what kind of a graph we are getting, but it's not clear, although it's right skewed because it's starting from 0 and there are no values till 2.5, and most of the values are concentrated here. So anyways, we'll have to clean this data to see a more beautiful picture of a box plot and histogram drawn over this data variable. So let me see how many of my columns have non-null values or missing values. So for that, I just did a quick info. So I'm getting that my app has 10841 as non-null values, similar to the shape, that is similar to the number of rows I have, which is 10840. Now this also category has the same, because the indice was 0, 0 to 10840. So these are the total number of non-null values that I have. Rating has kind of missing values, NaN values. I can see it from here. And also current version and Android version are having some missing values. So the next step is gonna be data cleaning. So let me see. From info, it's clear that there are some missing values, but not that much clear. So let me draw a true false thing over the whole of my dataset to see if there is actually a null value. So till here it's gonna giving me false, but as soon as I reach the end of my dataset, I can see that there are some true values over here, which means that yes, there is some null data in my dataset. But this is not also drawing a clear picture for me. So I just counted the missing values in each column. So for that, I just simply did is null dot sum. So I ran this function over here and then I ran sum over here. So I can see that my rating column has 1474 missing values. Content rating has 1 missing value. Current version has 8 and Android version has 3 missing values. So what to do with these missing values? We'll see it later. So, but we have found one anomaly out. Also, from the box plot and histogram, it was clear that there is one outlier, but let me see if there are some more. So I just ran this query over here. Running this cell is indeed giving me just one row in which I have 19 as my rating over here. So there is just one outlier. What I did to this was I took this variable. To this I passed that I want a column value such that Google underscore data dot rating. So this column value is greater than 5. So now this whole became a row. I ran the cell and it's indeed giving me just one row which has an outlier, that is rating value is 19.0. So what I did here was that I passed this greater than 5 condition to Google underscore dot rating column. So get me all those values from the rating column that are more than 5 because this is not what I want. And so I'll remove this row simply. I don't know if all the other values in this row are true or not, so I'll have to remove this. So what I'll do, I cannot supplement it with any other value because 19 is an overrated value, it's an outlier. So I cannot even replace it. It's not a blank, but it's a false value. So I'm removing this row. And what I'm doing is simply picking up this index number and dropping it out. And I'm performing these changes in place. That is, I'm performing this on the data set that I have stored in my notebook. So when I run this, now I'm running, I want to see if this row has been deleted or not. So I'm simply viewing the rows from index number 10,470 to 475. And indeed the row with the index number 10472 has been removed. Now let me draw a box plot and it's showing me the true values from 0 to 5, no other values till 19. And it's showing me that there are some values, some little values from starting from 1 to 3, but most of my data is concentrated over here between 4 and 4.5. So if we'll analyze this more, we'll see the visuals of this later. And let me draw the histogram also after removing that outlier. So it's indeed rightly skewed. And for rightly skewed or left skewed data, we generally prefer that we use median instead of mean, as you all must be knowing. So next step is I'm gonna be filling all my blank rows with the median value. This step is not necessary for this type of data set because we have seen that most of the columns have 90% of values filled in them. But in some of the data sets, you might come across a situation wherein the data is 90% empty. So you would just want to drop that column and not perform any data analysis on the same because we are having a scarcity of data in that particular column. So I'm just setting a threshold, which is the length of Google underscore data, which I'm sure is gonna be 10840, and multiplying it with 1. That is, I'm taking 10% of my rows count and this comes out to be 10840 because my rows are 10840 in number. So 10% of that value is 1084. Now I just want to drop that particular column which has a threshold, which has values less than my threshold, which has 10%, which doesn't even have 10% of my values, and I want to perform this in place again. And dropping means this time I'm gonna be dropping my column, not my row. So axis is 0. Axis equals to 0 is for row, which is by default, while axis equals to 1 depicts that I'm dropping a column. So I'm drop NA is the method for this, and thresh equals to threshold, comma axis equals to 1, in place equals to true. So I run this, and then I'm gonna be printing all the blank values that I have now. So if I run this, I can see that none of my column has been dropped, and still my column's shape is 10840, 13, because none of my columns have such type of data which has 10% only. So next we'll move on to data imputation and manipulation. So for that, I'm gonna be filling my missing rows with mean, median, or mode. So for my categorical values, I'm gonna be using mode, but for the numerical values, I'm gonna be using median, not mean, because my data set is certainly right skewed. So I've written a function over here, impute underscore median. It takes a series, that is a column, and performs this function series.fill NA, that is fill those values which are not there, blank values, with series.median. So this is a pandas function median running on my series. So now on this column rating, I'm passing each value to my function and performing a transform of this. Now let me check how many empty values do I have in my data set. So is null.sum is giving me that my rating column has been filled with all the median values. So all the empty data in my ratings column has been filled with median values. Now let me quickly fill the missing values in my categorical columns, namely type, current version, and Android version, with mode values. So for that, I'll first check what my mode values are for these columns, because there can be bimodal values as well. So you have to be a little cautious. But fortunately for me, the mode values for this type column is just unimodal, which is free. Again, a unimodal value for the current version column varies with device, and also a unimodal value for my Android column, which is 4.1 and up. And I'm quickly gonna be filling my empty data with fill NA function by using this function. So I'm grabbing this column, applying a function fill NA with a string value of mode. So here I'm being a little cautious. If there was a bimodal value, I'm choosing the first value from the two mode values that I may have got. And I'm performing this function, which is in place equals to true. So for all these data, because they are categorical values, I'm encapsulating it, typecasting it with str. All these mode values, I'm typecasting it to string and doing in place equals to true. Otherwise, it's gonna give you an error, because this method can only be performed on a numerical data, but you're enclosing it with a string, so it's gonna be fine. So I'll just run it, and then I'll quickly see if these null values in each column have been filled or not. So I'm performing the same function is null dot sum over my Google underscore data variable. So I see that now the rating value column has been filled, and so has been filled the type and current version Android version column with their respective mode values. Now just one thing remains, that is I want my price column, my reviews column, and my installs column to be numerical data, not to be categorical data, so that I can perform a data analysis on them. So I'm grabbing this piece of my column from Google_data, and I'm applying a lambda function to it, which says that please convert each value which is in this column. If it has a dollar sign in it, then just remove it with a blank. Otherwise, if there is no dollar value, let it remain the string value itself. Now all these values in my price column have been converted to strings. The dollars have been removed. Now I want them to be converted back into float values. So I'm just performing this lambda function. I'm applying this lambda function to the values of my price column. Next, I want to just numerically convert all my reviews because there is no such anomaly. And so I've just simply said to my pandas that please apply the to_numeric function to reviews column, and if you encounter any errors while doing so, please ignore that. So this is the meaning of course. Once I'm done, I have done the same thing with installs because installs need the plus sign to be removed as well as the commas between the numbers to be removed, and then all of these things have to be converted back to float. So let me just run this cell. And now I'm gonna be seeing if all of this cleaning has been applied to my 3 columns of price, reviews or installs or not. So I'm just running this Google_data.head. I'm seeing the first 10 rows. And indeed, my installs don't have a comma or a plus sign now, and have been converted into float. The reviews column is also very clean. It's got all integer values, all numeric values as we see here. And my ratings column will also be fortunately have been filled by now, and my price columns have now numeric values, float values. So just let me see if this has been surely done or not. I'm still not sure, so just let me go and see my summary stats now after cleaning, and I can see that I indeed have 4 rows. So 4 rows means that my central limit theorem is being applied to all these numerical columns. First it was for only for rating. Now this is also valid for reviews, installs and price. Now let's move on to data visualization of all these numeric columns that I have just cleaned up. Let me just perform grouping of this data on the basis of category. As you can see, I have numerous categories over here, which are art and design, auto and vehicles, beauty, medical, social, sports, video players, and so on, weather apps. So what this grouping is doing is that it's sending all my apps. So suppose an app with a name A, a name B, and a name N, and a name M belongs to the category of arts and design. So it's grouping all these apps together, the game apps together, which was suppose like 7, 8, 9 for the game apps. So it's grouping all these together and storing it in this variable grp. Okay, now from this grp variable, I'm extracting my rating column. So whatever the grouping has been done, I'm taking the rating column and aggregating with it with mean, which means that suppose in this category art and design over here, if I have suppose 13 apps and they have different ratings. For example, some app is having 4, some is having 3, some is having 4.3, some apps are having rating as 5, and so on. So I'm just finding a mean of these ratings and storing it in my variable x. So I'm just performing an np.mean, aggregating them. Aggregation means that combine all the ratings of these similar categorical apps, that is apps belonging to the same category, and take out their mean and store it in this variable x. So just performing this on this column of rating. Then I'm performing this aggregation on reviews also, that is taking the mean of the reviews, that is how many reviews each category has, taking the mean of that. For price, I'm just summing it up because if you have suppose 12 apps belonging to games category, so I'm more interested in looking how much money did this category of apps made rather than looking at the mean of their values. So for your convenience, I have printed all these variables, that is x, y, and z, that have been grouped, and here is the result. So the mean value of suppose this game apps is 4.2, while the sum of its price over here is 287. The highest prices being of family apps, of finance apps, of medical apps. And the same goes for my Z series for the reviews column. Let's see how can we visualize these variables that we have just formed through grouping. So let me show you a procedure of how I plotted these. So what I did was just plt dot plot, and I took this variable x and pressed shift and enter. So I got this line plot, but I didn't want this. So I introduced this RO, which stands for that show me this plot with respect to bubbles. So this is what I got. But then I noticed that this X label is very clumsy. So to fix this up, I just wrote X sticks and put the rotation of all these to vertical. That is, rotation equals to 90. But it's showing me also a list of these numbers which I don't want. So I just did a plt.show, and this is what I get. But this plot of mine is very small. So I wanted to span this width of my notebook so as to have a clear picture of what's this depicting. So I just did plt.pick figure, and I put in this attribute which is fig size equals to, then in a tuple I wrote the length to be 12 and the height to be 5. Then I pressed enter and this it got bigger. So next I went in and wrote the title, which is category wise rating, the X label to categories, and my Y label showing me the rating. And also by default the color is red. You could have used color equals to blue, color equals to green. So these are all the things that have been provided by default to you with respect to matplotlib. So let me reset it to red. And I did the same with Y, but over here I introduced the symbol r minus minus, that is show me dashed lines. And for Z I did BS, which stands for show me square shaped, or you could have gone for triangular shaped also, which is G cap. This is how it looks like. And from the plots I can see very clearly the highest rating have been to these events apps, to this education apps, to these weather apps also, to personalization apps, to my art and design apps, to my books and references. So these are the top category apps that have received a highest rating. And the pricing, so what people are mostly buying from Google Play App Store, so it's finance apps that they're buying the most. But to finance apps the ratings have been a bit lower, so like 4.15 to 4.20. Then people are buying lifestyle apps, then medical apps. For games it's relatively lower. The sum total of the game apps is relatively lower. So high priced apps are finance, family, lifestyle, and medical. Next I went in with the Z, which is number of reviews. So most of the reviews people have given on communication apps, then on social apps, and then on game apps. So these are the top 3 categories for this. So this is how you can plot and derive conclusions from your data and visualize it also. So this is all. Thank you for watching.